Hi everyone, my name is Desmond Stubbs and today I'll be presenting Lab 1, which was about constant velocity. So the purpose of this lab is to observe the motion of an object that moves with a constant velocity, and this was able to be done by comparing the observed velocity of the object with a computational model of the object's motion. So some details within this lab are the system was the moving object, and we were able to get the observed position graph from the database tracker and the predicted position graph from GlowScript. So some conditions within this lab is we had an initial position of 0.02802 meters, an average velocity of 0.306 meters per second, a delta t of 2.433 seconds, and we conducted the lab by pushing the object shown in the picture along the ruler, inserted the time while the object was in motion. And through this, we were able to use Tracker to get the distance every 0.03 seconds, which allowed us to get the observed position graph. So some concepts that we used in this lab was Newton's first and second law. Newton's first law states that an object in motion stays in motion unless an external force acts upon it. So our object stayed in motion throughout the whole video since there were no significant external forces that acted upon it. Newton's second law gives us the momentum principle, which is where we're able to derive the velocity update formula and position update formula. And with the velocity update formula, we were able to say that the net force was 0 since there was no net force acting upon the object. And as a result, the final velocity equaled the initial velocity. So within this graph, we have a position versus time graph here. And the green line in this graph represents the model from GlowScript, and the blue line represents the observed data from Tracker. And you can see that the blue line is slightly lower in position after 2 seconds. And this is because it takes into account the friction and external forces that would have interacted with the object. And as a result, it could have lowered the velocity, or it would have lowered the velocity, which is why the blue curve is lower in position after those 2 seconds. So within GlowScript, we input our initial position of the 0.02802 meters and the initial velocity of 0.306 meters per second, and change the delta t to 0.033 seconds to match the observed timestamps. And our net force was 0 since there was no external forces acting upon the object. And through this, we were able to get the graph on the right from GlowScript. And we can see that the line slopes upward, which means that the object was moving forward with a positive velocity. So if we flip the axes, this would have resulted in the slope being flipped towards the negative direction, and as a result, it would have produced a negative velocity due to the slope being flipped in the negative direction. So is it possible for you to say how many pushes and pulls or forces are being added together to give a 0 net force in the case that you observed? I would say yes, because within this experiment, we know that there are 2 forces acting on the object, the force of gravity and the normal force, which are equal and opposite forces in this case. And this would result in the net force equaling 0 since these forces cancel out. So some sources of error from this experiment could have been from the moving object touching the ruler. This would have resulted in some friction within the 2 objects, which could have lowered the object's velocity. And another source of error could have been from inaccurately placing the center of mass on the objects on the Tracker database, which could have resulted in some inaccurate position data points within the graph that was produced by Tracker. So thank you.